Okay, good afternoon. Welcome to our session on API security. Thank you very much for attending. So I represent a company called Noname Security. I won't give you too much detail about what we do initially. We have a booth if you want to see the product. But one of the reasons I chose my friend Clint here is that in the movie he portrays a character that's called the man with no name. So I thought that was a good fit to start talking about API security. What I'll do in this 44 minutes or so is talk about information security, API security, and a little bit about no-name security as well. So it's all about security and securing APIs. Before we dive into APIs specifically, I wanted to take a step back and look at IT security in a bit of a broader perspective. So when you think about securing IT environments, it's often a little bit misunderstood or looked down upon in a sense that it doesn't really contribute to the stuff that you're building all that much. So I tend to compare it with meerkats. So meerkats, they live in groups of 20 to 50 meerkats, and one of the meerkats is designated as a sentinel that sort of looks out for trouble and keeps watch, so the other meerkats can burrow their holes and can gather food. So the idea is that the actual product that they want to build is to build these homes, is to build these burrows, to gather food and to compete with other meerkat clans and other animals that live in the same environment. So that's really the goal of what they're doing. But without this sentinel meerkat, none of that is possible, or at least it would be very, very short-lived. So in terms of security, that's sort of the same thing that we tend to need to think through, in my opinion. Now, when you talk to security with higher level management, like if you go to C-level and the board and so on, they don't really think about security as such. They think in more abstract terms. So what they care about is three main things mostly. It's about making money, saving money, or avoiding risk. That's what they think about all day, every day. So whatever you're doing has to sort of fit within those three areas of concern. Otherwise, they won't be very much interested in what you have to say. Of course, when it comes to security, we're mainly in this avoid risk type of scenario. Now, if you classify risk or information risk, I think one good way to think about it is you take the likelihood something is going to happen, you multiply that with the impact. Let's say there's a ransomware attack. What would be the impact of a ransomware attack, and how likely is a ransomware attack to happen in my environment, for example? That gives you a sort of risk score that you can put on a risk matrix. And depending on the organizational appetite for risk, you then say, okay, this is something I'm going to be able to live with, or I'm going to have to invest money in technology and people to make sure we can lower sort of that risk score overall. Now, sometimes management needs a forcing function when we think about security. So one example was the recent Uber breach, where a lot of public information was out in the open, including things like travel and expense budgets of VPs, and they don't like that if that's out in the open, if you can see how much money they're spending on travel and expense. But what was interesting here is that you see that sort of the breach was, or happened September 16th, and then all of a sudden they had a lot of openings on LinkedIn for security personnel on the same day. So that's sort of a forcing function for Uber to really start to think about, oh, actually, there was already somebody asking for this headcount in terms of adding, let's say, adding people to the security team. They always probably got no as an answer, and all of a sudden there's this problem, and this is how they respond to the problem. So that's sort of how you think through risk at a higher management level position. Now, being a CISO is a pretty tough job. So the CISO of Uber, he is indicted. He will most likely go to jail. This has nothing to do with that recent breach. This is about a data breach that happened in 2016 when they lost about 57 million user records. But if you are a CISO in an environment, that's how the CISO looks at risk. Is he either, let's say there's a breach, and he or she either acknowledges the breach and loses their job, or he hides the breach and then goes to jail afterwards. So it's a really tough position to be in as a CISO when you think about security risk. So if you think about how people get into an organization initially, it's typically one of 5 things. If you can think of more things, I'm interested to hear what they are, but To my knowledge, it's either unpatched vulnerabilities, it's security misconfiguration, it's weak, leaked, or stolen passwords, it's social engineering or insider threats. Those are the 5 main things how people initially get into your organization. And that's sort of, from a security perspective, how we think about risk. So it falls into those 5 categories, and that's how we start to sort of secure our environments. So if you think about the equation again, what's the likelihood one of these 5 things will happen? What's the impact of one of these 5 things happening? That's sort of my risk appetite, and can I live with that, yes or no? So why are people going after APIs specifically? I think this was first quoted in a Forbes article or something a couple of years ago, where people started to say data is the new oil. In any case, data is super important. It's sort of what drives organizations. It's typically where your uniqueness as an organization lies as well. So you can compete on the world stage, but the more data and the more knowledge you have about your products, about your consumers, about your competitors, that's really sort of what sets you apart. So data is sort of the main thing that we're after as an organization, and the way to get access to that data is through APIs more and more. So from an attacker perspective, that's why APIs are now so interesting, is they're sort of the pipeline between the consumer of that data and the producer of that data. So if they can get sort of into that pipeline system, that's where a lot of the data will be transferred, and that's where a lot of the knowledge can be gained. Now, one recent example is Optus in Australia. So they had a breach. There's some discussion about what the actual reason of the breach was. Some people claim it's a completely unauthenticated API in testing. Others said it's a beta API with some authentication. It's sort of differences of opinion. In any case, they were breached. So this was a reporter in Australia that reached out to the company and to some other people who basically confirmed that this was the API in question. The API is no longer there, of course. They took it down immediately. That's sort of what you do to stop the bleed. But the other thing that we do as developers is we publish all of our stuff in GitHub. It's still there. So if you go to GitHub, you can see the API. And one of the things that's happening here is that the way they enumerate customers is just by incrementing a number. So there's no hashing or anything like that. So once you understand sort of the string that a customer represents and you increment it with 1, you can read the entire database of customer PII information. So that's quite troublesome. So the assumption now, it's an unauthenticated endpoint with a BOLA vulnerability that led to this breach. Fairly problematic, so it's between 11 to 8.7 million PII records, again, depending on the source. But what Optus is now proposing is that they will pay the passport costs of those people who were impacted by the breach. So it's going to be a very expensive situation for them. Because it's APIs, and APIs sort of interconnect everything, think about those pipelines again. That's basically what we set out to build. Fixing this is problematic as well. So this is an example I found on Twitter. So this is a person logging into his Australian bank account. He's not even an Optus customer, but when he logs into his Australian bank account, he gets the message. Because of the Optus breach, if you see like weird stuff happening in your bank account, it's probably time to like log out and burn all your passports and stuff, right? So everything is sort of interconnected and sort of woven together. So if you think about that risk again, the likelihood of an API attack happening is very, very high. There's many examples out there, and I'll give a bit more in just a few minutes. The impact is very, very high as well. So the risk is extremely high when it comes to APIs. Problem, though, it's a bit of a, let's say, attack surface that's under the water a little bit when it comes to traditional info security personnel. They don't tend to think about API from a risk sort of perspective, or at least they consider API security to be part of their existing security controls. The other thing that's sort of happening more globally is this concept of a super app, whereby more and more functionality is, let's say, consolidated into one single application. This is a screenshot of my banking application in Belgium, which is really bad from an operational security perspective, I know that. But just as an example, so what I can do here is if I log into my banking app, I have this option to start my parking for my car. So I can push this button, and then it will pay for the parking of my car wherever I sort of am in Belgium. And this uses a service called 4411. This is a famous parking service in Belgium. So I'm using this happily because it's integrated, it's super easy. I don't need a specific account for 441. I trust my bank, everything is fine. And then a couple of days later, there's this ethical hacker in Belgium who figured out that through using APIs, he can read all people's location through this 4411 app. So you can just query this API and get a latitude and longitude of where your car is parked, and they can find wherever you are in Belgium at that point. Which is interesting if you combine it with the fact that we, in Belgium, recently had some threats against people in the government, and as a matter of public record, their license plates are publicly available. So they can track them wherever they are. Everything is interconnected. It's really bad. So how do you take a bad situation and make it even worse? You introduce Elon Musk into the mix. So what this gentleman is now doing is he's proposing to buy Twitter. That's well known and well understood. But what he's now proposing to do is to turn Twitter into WeChat. That's what he's going to model it after. So WeChat is this application by Tencent used in China, and they use it for everything, right? It's a social media platform, but it's also their payment application. They use it for everything, basically, in China. So what he's proposing is to also turn Twitter into this super app and get all of this functionality centralized. So again, something in terms of risk we definitely need to think through. I said I was going to point out a couple more examples of API-related breaches as well. So the first one is Peloton. So this was a couple of years ago already. They had an unauthenticated API you could query and get PII information from users back. Things like their age, their weight, how many times a week they trained, how much weight they were losing on average, etc. And one of the users happened to be the current US President, Joe Biden. So this is pretty bad. Like if you have this person whose health information is kind of valuable to certain people, and you can just query this unauthenticated API and get this information back, that's problematic. The second example is Shopify. So Shopify is a Canadian e-commerce platform that people use to build their e-commerce websites, sort of from templates, let's say. They have an API for what they call collaborators. So what you could do is you could register yourself as a collaborator for any website in the world, and then you can read their stock information, you can check what their prices are, how many people are visiting their website, how many people are buying stuff. So again, out in the open. And then the last one is USPS, so United States Postal Service. They allow you to query the location of your package, which is a super useful tool to have. But what you could do is that object ID to query your package, again, wasn't really hashed or anything. It's enumerated, like it counts up with 1. So as long as you have an idea what that object ID looks like, you could query everybody else's package as well. And then you could figure out who's getting a package and drive over there and receive their package in their stead. The final quick example I wanted to talk about is Coinbase. So this was in February of this year. And I found this super interesting. I'm a Coinbase user myself. It's super easy. This is not investment advice, by the way. So what you could do with the Coinbase application, or the problem they faced, was they had a trading API. Actually, this was in beta, so it was not out in the public. And this was disclosed by the hacker who found the issue via HackerOne. But what you could do is you could have 2 accounts in Coinbase. One account, you had your Bitcoin. The other account, you had your very cheap alternative cryptocurrency. Let's say Shiba Inu, as an example. And what you had is you had 0 Bitcoin in account A, and you had 100 Shiba Inu in account B. What you then did is you started your transaction for Bitcoin, the first validation that happened was, does this person have the coin that he wants to trade? Yes, he has Bitcoin. They did not check the amount of Bitcoin that they had. He logged into the other account. Then they checked, does this person have 100? Yes, he has 100. Doesn't matter if it's Shiba Inu or Bitcoin. And then he could trade 100 Bitcoin versus US dollar for the price of 100 Shiba Inu. So again, sort of BOLA issue, business logic issue on the back end of your APIs, which is almost impossible, if not completely impossible to detect using any traditional security means like API gateways or web application firewalls. So that's really the problem that we're dealing with. From a Noname perspective, we did some research as well. So we commissioned an independent researcher called Alyssa Knight to look at some banking applications. So she validated 55 banking apps and sort of found that this was universally true across all of these banking apps. So most of them have hard-coded API tokens and usernames and passwords to external services as part of the software package, which is troublesome. All of them were open to a proxy attack, so a man-in-the-middle attack, so you could read information in the clear, not a problem. All of the banking apps had BOLA vulnerabilities, and all of the banking apps had broken authentication vulnerabilities and broken function level vulnerabilities as well, whereby if you logged in as a certain user, you could start trading for all of the other users as well, because there was no more validation after that point. And the last one is kind of interesting as well. So this is what she figured out is that one of the companies as a third party that was hired to build these applications was selling the same code base to multiple different customers, about 300 of them. And they were selling their vulnerable code over and over and over again. So all of these banking customers sort of ended up with the same problem. You can get the white paper with all of the details on that link there as well. This was recently sort of validated, I should say, by Symantec. So Kevin Watkins, a security researcher at Symantec, he looked at mobile applications, a couple of thousand of them, and found that most of them contain indeed API keys or credentials to cloud-based services or SaaS-based services. So this is a problem that's really persisting as well. So what do we do about it? How do we fix this? The first question you need to then ask is, who is responsible for fixing it? So there's a lot of people that are involved with building APIs, of course, and also a lot of people involved with securing APIs. So it's developers, it's the API team, it's the application security team, it's the network security team, it's the information security team, it's the product owners. So there's a lot of people who have something to say about your API estate. And that's also sort of reflected in the tools that we are using to secure those APIs. So from a information security perspective, we have things like web application firewalls, we have gateways. From a developer perspective, we have good coding practices, we have linting tools, we have SAST tools, we have DAST tools. So we have a myriad of capabilities to look after securing APIs. So if somebody from management sort of comes down and says, we need to secure APIs, it's really problematic, because where do you secure your APIs? So this is really the problem that we're trying to target. Now, let's assume we say developers are initially responsible for securing APIs, or at least delivering secure APIs. Turns out that doesn't track. Like, developers think about security differently. So this is from a white paper from Secure Code Warrior. I pulled this from an AWS session. So where they saw that only 14% of developers consider security a top priority. So if we say developers are responsible for API security, we still have quite a ways to go. Another thing I looked at was, so how do the security vulnerabilities get inserted into the code? So the first thing I did is I looked at some research. This is very old research from Tandem. So Jim Gray in the 80s looked at their Tandem machines, which were renowned for their high availability. These Tandem machines you could not break. They were super reliable. And what he did was, like, if they break, what's the reason these faults occur? So we looked at the code, and then he figured out that when engineers say the code is ready and they check it in, it contains 1 bug per 10 lines of code. Then when QA works on the code and does their validation, it goes down to 1 bug per 100 lines of code. And then after a few years in production, many patches later, it goes down again to 1 bug per 1,000 lines of code. Now, of course, you're going to say, this is research from the 80s, and waterfall is dead. Actually, it tracks with what we're seeing today as well. So this is from Applied Software. And what they looked at is, where do bugs or vulnerabilities get inserted during which phase of development? So during coding, unit testing, functional testing, system testing, and release. And what is the cost of fixing a bug in these different stages of development? So of course, let's say the majority of the bugs and the faults get inserted during coding. That's quite obvious. So the idea there is, if we can catch them during that initial coding phase, the cost of fixing those bugs is really low. Is comparable to just writing the code, essentially. The longer we wait, the more costly it will become. So the idea would be, from a developer point of view, is to help them develop secure code as early as possible. So the question is, how do you do that? You have to make that very seamless, right? So there's a lot of talk about shift left in the industry, and shift left for everything. So there's people talking about shifting observability left, shifting testing left, shifting security left. So at the end of the day, everything is going to be shifted left, and the developer has to take care of everything, which is not realistic. So if we want to avoid developer burnout, as this nice gentleman writes there, we have to figure out to make security testing a seamless piece of that development lifecycle. Like, it has to be incorporated without too much heavy lifting. So if we think about that picture again, where you had the API gateway, you had the web application firewall, you had the developer, you had the security testing, and we asked the question again, like, who is responsible for API security? Then the answer is yes. So everybody is responsible for API security. One of the problems is we don't understand the attack surface. So this is from a survey by HackerOne, which is a bug bounty program. And they sort of asked 800 of their customers about how much they understand their attack surface. So what do they think they know about their vulnerabilities and their exposure? And 1/3 of respondents said that they monitor or are aware of less than 75% of the attack surface. So there's 25% of stuff they externally publish that's available internally, etc., that they don't really know about. Of course, the cardinal rule in security is you can't secure something that you don't know about. If you can't see it, you can't really secure it. So step one is understanding what you have and building sort of that inventory. So this is sort of the reality that we have to deal with day to day, really. So why does this problem exist? We have so many tools. We are spending so much budget on security and implementing all of that. So why does this gap still exist? Specifically for API security, it's about missing context. So if you think about this picture here, so I'm sure you've heard about the blind man and the elephant, whereby depending on where you're looking at the elephant, you sort of see different things. So if you're looking at this picture, you're saying, oh, it's a tree trunk. If you're looking at this picture, oh, it's a very big snake or whatever. But unless you take a step back and look at the full picture, that's when you're going to understand what does the full context mean. And especially with APIs touching so many different systems, this is paramount. So really, you have to understand what the attack surface of an API looks like by stepping back, but integrating with those tools, right? So all of our customers already have a web application firewall. All of our customers already have an API gateway. That's the bare minimum that we want. And we now want to extend that with that additional context to pull it open and sort of show them the full API vulnerabilities. Luckily, it's not just me who is saying this. It's also our friends at Gartner and OWASP as well. So it's really hard to use these static vulnerability checking tools, let's call it like that, to validate what an API is doing, because most of the API vulnerabilities live in the business logic. Once you're authenticated, once you're authorized and you're using an endpoint, it's very hard then for the gateway device to decide, well, is this allowed? Yes, there's scope, but once you're sort of past that, you can do whatever you want, right? So if you forget to implement RBAC on your objects, you're screwed and your gateway doesn't know it. So when we look at all of these point solutions, they do have a lot of use, and they are super valuable in the entire, let's say, end-to-end discussion of security, because security, of course, means defense in depth, and defense in depth means many, many layers. So we do need all of these layers as well. But each individual point solution doesn't really give you the context of what my API attack surface looks like. It just sees like the trunk of the elephant and the leg of the elephant, and it doesn't get the full picture. So one part of that from an API perspective, if you talk about context, is this example here. So let's say I'm talking to an API at Twitter. The method, the hostname, and the path give us an initial context already about what is going on. Meaning, if I do a get to Twitter/v2/users all, that's very, very different from a context perspective than doing a delete to that same endpoint. Yes, you could implement this at a gateway level. Of course, you can implement this at a contract level, but I mean, from a pure information security perspective, those are two completely different things. Another example is if I do a post to user acceptance testing.twitter, or if I do a post to twitter.com, again, that's completely different context. So that's what the security platform needs to start to understand to ultimately give you an interesting response to what is going on. So if you talk about authentication, authorization, those things are super necessary, of course, but think about it this way. A lot of implementations I see, we are talking about, let's say, production APIs, pre-production APIs, partner APIs, business-to-business APIs, business-to-consumer APIs, and they're all managed differently from an authentication and authorization perspective. Like maybe your pre-production APIs only need an API key. Maybe your production APIs, if they're business-to-business, need SAML authentication. Only if they're talking to a consumer, they're going to do OAuth, for example. So all of this has to be managed, also from an authentication gateway implementation perspective. So that makes it really, really hard for a security person to follow along and understand how is this working and how is this interconnected. An additional factor that sort of tricks your gateway devices or tricks your web application firewalls, if I can call it like that. If you think about traditional HTTP applications, it's a small number of calls that are happening to read the application and give that information back to, let's say, your web frontend or your Chrome browser or whatever you happen to be using. If you're talking about APIs, every piece of functionality is a different endpoint. So there's a lot of calls going on. So Cloudflare, the CDN company, they looked at API traffic on their network. And it's very hard for them to start to differentiate between good and bad traffic because the amount of traffic is so enormous when it comes to APIs. So from a security perspective, if you put, let's say, a gateway in between or a firewall in between, that system now has to deal with this influx of data and has to start to differentiate between what is good and what is bad. And that's really part of the crux of the problem. Everything that we do makes it worse from a security perspective. So we keep changing our minds about what is the best protocol to use today, or how do we develop our APIs. And one example would be, let's say most of the traffic is REST-based today. And from a security perspective, you have a consumer talking to an endpoint. If it's different functionality, it's probably a different endpoint. I can manage that from a security perspective. Let's now say it's a GraphQL endpoint. You have a front end and you have one single endpoint, and depending on the query you write, you get a different result back. How do I check that with my... Stop doing that. So that's really getting tricky. So the only way to actually overcome this is to implement one of the buzzwords of today, which is machine learning. So machine learning looks at all of this data and tries to really understand what is going on and use that to build the context from an API security perspective. Excuse me. So how we look at that specifically is we look at 4 key elements. So this is sort of our answer to this problem is we look at the traffic. So what is the actual API communication? What does that look like? How many people are using my API? Is my API externally connected? Is it ever been accessed over the internet? Is it authenticated? Is it not authenticated, etc.? So the traffic really gives us a good understanding of how the API is being used in reality. Then we look at the code, and the code tells us things like, what is the API capable of? What does the API allow? So what primitive can I get if I talk to this API? And the other thing is, what does the documentation tell me the capabilities of the API are? And do the capabilities of the documentation differ from what I'm seeing from a traffic perspective? So those things you need to offset and validate against each other to really see, is there a blind spot in the organization about what they think an API is capable of versus what I'm seeing in reality? Are there unused fields, et cetera, et cetera? And the final piece is then the infrastructure. So an API is powered by something. Maybe you're running it on an EC2 instance in the cloud. Maybe it's a Lambda function that's powering it. Maybe it's running from a virtual machine. It's probably a combination of all of those. And then it's passing through the network, right? So that gives us additional context into how your APIs are being used. Think about, from a network perspective, I'm consuming an API, and there's a gateway in between, and that's how I talk to the endpoint. What if we see 99% of the people follow that path, but 1% is following or bypassing the gateway by directly talking to the backend API? That means there's a routing configuration somewhere in your environment. So looking at that infrastructure actually gives you a lot of context as well. So I mentioned the buzzword already. So machine learning is sort of what we use to make sense of all of this data. And what we have to do then is we have to try and understand how are people using my APIs? What is the baseline I can gather from that? So if, let's say, 99% plus of my consumers are using the API in this way, that gives me a lot of understanding about what potential misuse of that API might look like, and that's how I can respond to that. So one example would be, let's say, I'm a user and I'm querying an object in a database, and typically there's a one-to-one relationship. So I'm a user and I query my own objects in the database. And that's true for 99.99% of the people. And then somebody else logs in, and this person queries 1,000 records across many, many different object IDs. That gives us then context to say, you probably have a BOLA issue or an IDOR issue in your environment. So it's that type of information that we really have to start leveraging from a security perspective to make it more useful. So I'll try to do a quick demo if the network allows me to do that. Just a second. So what I have here is I'm using an OWASP project called Crappy, or Completely Ridiculous API. So this gives you this vehicle website. As part of that application, what you can do is you can sort of query the location of your vehicle anywhere in the world. So the idea would be, let's say I'm going to quickly refresh this. And let's see what APIs are being used. Please, network. OK. So you can see, I don't know if you actually can. I don't know if you actually can see it in the back. But we're querying this specific API. So let's have a quick look at the response here. And what this API gives me in this example is it gives me a UUID, which is the unique identifier of my car. Now, what I can gather from that UUID, you can see it's a complex string, right? So it's not going to be something that I can easily enumerate and say, I'm going to guess what the next number in line is going to be and figure out somebody else's car. So you then, as an attacker, you have to sort of look for, is there an API somewhere that leaks too much information, for example, where I can gather some of this information? So one of the things that's wrongly configured in this web shop here is I have this community page. And if I go to this community page, there's a lot of people posting in this forum. And as part of their posts in that forum, what they do is they send their user information as well. The idea is that the backend developer decided to just send that user information and let the front end deal with it. So let the front end filter out what is not needed. And that's exactly what you want as somebody trying to enumerate APIs. So what you can see here is I have this person called Cordelia Kulas. And this happens to be then the vehicle ID of this Cordelia Kulas person. So what if I take this vehicle ID and I put it in my query here, and I do a get to that vehicle ID. Boom. So I'm getting a location back. So from a BOLA scenario, this is pretty bad, so I can access another user's info. Now what I'm going to do here quickly, just in being conscious of time, is I'm going to run a script that's going to, oops, that's not going to, sorry. So I'm going to run a script that's going to automate this request across all of these APIs that you see here below. And then if you look at our platform, oops, sorry. If you look at our platform, the way that we figure this out then is I have issues in my environment. So what I can see here is there's a broken object level authorization problem that I found. If I open this up, I can see that the API here that I've been querying, vehicle/GUID, what he's saying here, hold on. So what he's saying here is that the user has attempted to access multiple distinct API resources of that GUID. So in this case, it's just 2 because I did that manually. But a normal user only does 1. So a normal user accesses 1 object that belongs to, let's say, his authenticated ID. And in this case, I've done 2. So what we're saying here is this is suspicious behavior on the basis of machine learning, and this is something we then have to take care of. Now, what we've done here is we've identified this user on the basis of a JOT token. What I can do is I can go to my attackers view, and for example here, let's take this one. So these are all of the attack attempts that I tried to do yesterday. And what I can then do is I can ask to remove this identifier of this user, so access to the system is no longer allowed. So I'm going to say block attacker. We've identified a certain IP address as the identification of that specific attacker, and then I'm going to say block this user indefinitely and ask the inline device, in this case it's the AWS Web Application Firewall, to block that IP address. So what we're going to do is we're going to dynamically update the ACL on the Web Application Firewall in AWS to remove that IP address, so I can no longer talk to that specific API. Another thing that we can query then is, why don't I look at the payload? So what I did to prepare a little bit is I created a data type called API-con. And in that data type, I'm looking for a specific keyword. The keyword that I'm looking for is secret Wi-Fi code. So what if I'm using that API, and from a data payload perspective, I'm going to go and I'm going to add a comment, and I'm going to say secret Wi-Fi code, add comment. And then I go back to my system here, and I'm going to look at my issues, and I'm going to see that I have a data policy violation that says well, somebody put in this case as a request, put in the secret Wi-Fi code. So that's a problem, and you have to block that. So the idea there is you can augment your existing tools with this capability to bring that additional context of API security into an existing environment and sort of allow you to, let's say, extend the knowledge of the attack surface to include API security as well. All right. So to sort of wrap up really, really high level, what the platform from a Noname perspective does is we have sort of 3 main pillars in terms of capabilities. We allow you to integrate into your development lifecycle in pre-production to develop secure APIs. If you want to see a demo of that, you can come to the booth. Happy to show you. And then posture management and runtime is what you just saw for production. So once there's live communication going to those APIs, what can we learn from that communication to give us that additional context when it comes to API to then secure that traffic and make sure that no malicious activity is happening. So I have one quick takeaway. We do run an API security workshop regularly, a lot of the time online, sometimes in person as well. The idea is what we do there is it's 3 or 4 hours. We'll walk you through some, let's say, broken APIs and broken applications, how to attack those APIs, and how to then use that knowledge to secure APIs and implement good security controls around it. So I highly recommend if you have some time to attend one of those workshops. So yeah, you can just go to nonamesecurity.com and you'll find it. Or pick up a folder at our booth, and that will point you to it as well. So with that, I'll just want to quickly stop for questions, if there are any. No additional questions? Great. Thank you very much. And yeah, if you want to see a full demo, happy to show you at our booth. But thanks for coming to the session.